So this is lesson 4.2. We'll start out with video A. This will not be near as long as 4.1 is as you work to understand all this. And so what we're going to do is we're going to use a lot of the same stuff that we did in 4.1. We're just going to add to it a little bit. And what we're going to do in this section is we're going to translate our graphs to different places. So up until this point, we had a graph that maybe the amplitude changed by putting a number in front of the sign. The period changed by putting a number in front of the x, like that. And so that's what we did in the last lesson. What we're going to do with this lesson is maybe this graph shifts over this way. So it moved to the left a certain distance. So that's a translation. That would be a horizontal translation. And then we've got vertical translations that we'll deal with later. So a horizontal translation is called a phase shift. So, whoops, wrong button. Phase shift. Alright, so the formula is defined by this. So that means that when we have our equation like up here, notice that we have a minus pi over 3. Pi over 3 is our d here. And whenever this number is less than 0, we have a phase shift to the left. So the whole graph will go to the left this many. If this were a positive number, the translation would be to the right. So notice we have an x minus pi over 3. This is my formula. The x minus already exists. This part of it is not part of the d. So then you have to look and say, is pi over 3 a positive or a negative number? Well, it's a positive number, so that means d is greater than 0. So that means this thing is going to shift to the right. So don't assume that this negative is going to determine whether it shifts to the right or to the left. It's the d value that we're concerned with. So we're not concerned with the x minus. Pi over 3 is what we're looking at. If this thing here were x plus pi over 3, that has to be put in that format. So it's going to have to be written as x minus. Well, x minus what? X minus negative pi over 3 in order to make this positive. So we're always going to write it as x minus, and then we're going to look and see if this says x plus pi over 3, then this had to have been x minus a negative pi over 3. So therefore the d is negative here, so it would shift to the left. So very important to remember that part of it as you're doing these. Alright, so let's go ahead and look at this example, and we're going to get this graph out of the way so that we can get started here. Alright, so if you remember from last lesson, we did some things with tables, and we're going to continue to do the whole table thing with this. So first of all, what we're going to do is we need to come up with my period. We need to come up with our intervals so that we can start making the table. So first of all, we've got our period. Remember, our period is 2 pi over b. And where is our b? Our b is normally a number right there. There isn't one, so that means that our period is just 2 pi. There's no b there. It's 2 pi over 1. So our period is 2 pi. So that makes it good. So that means our interval is 0 to pi. That's how long it is. The problem is, because of this number here, there's a shift. So it does not start at the point 0 and go to 2 pi. It shifts. So in order to do that, what we do is we take 0 less than or equal to x minus pi over 3. So we take this problem right there, less than or equal to 2 pi. This is very important because this will automatically shift to our beginning point and our ending point, because right now we've been practicing that this is our beginning and this is our end. It always begins at 0 and ends at whatever our period is. Well, our period is 2 pi, but it's moved over. So it's going to be a little different. So we start with 0, we end with 2 pi, which is normally our interval, or normally our endpoints, but we're going to put the equation here in the middle. And we're going to do some simple algebra. We're going to add pi over 3 here, pi over 3 here, and pi over 3 here. And that gives us pi over 3 when we add 0 plus pi over 3. We added that, so that's going to go away. And that's going to give us 2 pi over 3 plus pi over 3, which is going to give us 7 pi over 3 when we find common denominators and put those together. So now we have not only our 2 pi interval, but we also have the beginning point and the ending point on our graph. So we're going to keep that and get rid of everything else here. So let's go ahead and put that back up there. We had pi over 3 is our beginning point, and 7 pi over 3 as our ending point. And there's still, between these two numbers, if you subtracted those, you would get 2 pi, because that is how long my period is. It's just moved over. It doesn't start at 0, it starts at pi over 3. It doesn't end at 2 pi, it ends at 7 pi over 3. Alright, so now the next step was to divide those into 4 equal parts. So the way we're going to do this is a little bit different from the last section. The last section, remember, we took 1/4, 0 plus, say 2 pi, because that was the period. Well, the period's still 2 pi, but we're shifted. So we're going to do it a little bit different when we're shifted. And it will work even when you are starting at 0 and go into 2 pi. But what we're going to do is we're going to find the middle one first. The middle interval is going to be 1/2 x over 3 plus 7 pi over 3. So we're going to take those intervals, add them together, and take 1/2. So that would be 1/2 of 8 pi over 3, and that would be 8 pi over 6, which equals 4 pi over 3. So that's my middle interval there. So if I were to start at pi over 3 and go to 7 pi over 3, my middle would be 4 pi over 3. And what I'm looking for now is this one and this one. So what do I know about this point right here? Well, it's halfway between these two. So I'm going to use the same formula again. I'm going to take 1/2, but instead I'm going to use the endpoints that I'm taking half between. So I'm taking the endpoints right there. So that equals 1/2. 4 pi over 3 plus pi over 3 is 5 pi over 3, which equals 5 pi over 6. So that is what's going to go here. Alright, so now let's look for this one, and it's going to be based on halfway between those two. So I'm going to take 1/2, and I'm going to take this one, and I'm going to add this one, and that's going to give me 1/2, 11 pi over 3, which gives me 11 pi over 6. So this one in the here goes 11 pi over 6. So after erasing everything, that's what I have there for my x values. That's where something is going to happen. It's either going to be the highest point or the lowest point, or it's where it's going to cross the x-axis. Alright, so now let's take this part. X minus pi over 3. So I'm going to take my x value right here and subtract pi over 3, and I get 0. And over here I get pi over 2, and I get pi. I get 3 pi over 2, and I get 2 pi. Now what I'm going to do is I'm going to take the sine of that. So I'm going to take the sine of each one of these. When I take the sine of 0, I get 0. Sine of pi over 2 is 1, 0, negative 1, and 0. Which I should have been able to realize that I was going to have as my maximum value 1, because there's no number in front of the sign. So I know it's going to have to be 1. But where is it going to cross at 1? It's going to cross 1 at this point and this point. So those are my places there. Alright, so let's bring our graph back in here. And we're going to look at our x value of pi over 3. And at pi over 3, my y value is 0. At 5, and I go to 7 pi over 3, and my y value is 0. And let's look at the halfway. At 4 pi over 3, my y value is 0. Halfway between that is 5 pi over 6, and my y value is 1. So let's call that 1. And at 11 pi over 6, I'm at negative 1. So I get a graph that looks like this. So notice, my graph, like I said earlier, is shifted pi over 3 to the right. From 0, 0 over to here is pi over 3 of a shift. And that's what that tells me right there. So that is how to graph the sine of an x minus d. The next one we're going to do is a cosine, and that'll be on the next video.